That's a key part of the proposition, actually. So if you implement a cellular module in isolation, you come up with your own design, then the whole software piece on the board, the PPP dialer, maybe slightly old parlance now, but I'm sure those that have spent any time with AT commands will know what we're referring to there. There's an entire Linux operating system on board, vast number of subroutines to take care of things that even connection control, allowing remote reboots by SMS, that you need a handler to deal with all that stuff.
Hey, it's Eamon at the ipXchange studios for another in-person in-office demo. So we're here talking with David from Robustel. So first things first, we do have a board as always, but let's hear about, so what does Robustel do and what do they provide to design engineers?
So Robustel is a company that were incorporated back in 2010, and they're very much focused in Internet of Things, components, modules, focusing on 4G, 3G, 4G, and LoRaWAN devices in particular.
Cool. So that's a pretty broad spectrum of different communication types.
Yeah.
What kind of key applications do you see people using that for?
That's a good question. It's extremely broad. So there is transportation, industrial automation, digital signage, a whole raft of different communications applications where fundamentally things and devices need a connection to the internet. Cool.
So I can see this is a module, so there's much more than just one piece of silicon on there.
Yeah.
What's everything that's packed into kind of the typical Robustel solution?
So this is actually an example of Robustel's embedded options. This is an embedded 4G router. The primary component on there is the cellular module to give you the comms to remote servers, typically these days cloud-based, AWS, Azure, and very commonly MQTT traffic, which has kind of become de facto for us. And then on the local side, it could be anything, any kind of industrial protocol. We do loads of Modbus, loads of LoRa on the wired side, and then digital, analog, and any extension thereof.
Cool. So I saw that there's there was kind of this use of this embedded solution in products themselves, but also things that you called boxes.
Yep.
So can you explain what you mean by boxes as a solution?
From that perspective, that's one of these in a box.
Fair enough. Or just kind of if I said kind of like the fuse box for a building or something like that. Is that the type of?
Yeah. I mean, certainly energy is a big consideration for us at the moment because the vast increases in costs to all businesses across Europe. So whether it's in the fuse box, whether it's a CT clamp that goes on the main feed, it could be anywhere. It could be just literally a LoRa 13 amp socket sensor that then transmits wirelessly back to our board, and then our board gets it to the internet.
So let's talk about the board a bit. Obviously you've got the big Quectel chip on the top, but I can see a lot of connections. What are those three inputs or outputs?
So the antenna connectors, there's two cellular connectors, SMA, and one RPSMA Wi-Fi for 2.4 gig Wi-Fi.
Cool. And then on the other side we've got, is that two Ethernet?
Yeah, two Ethernet ports. And actually, so on the I/O lines, what is broken out on this particular product is either RS-232, RS-485, or a digital in, digital out, and ground, depending on what combination that you actually need for the application. The RS-485 is generally used for Modbus RTU.
Okay.
And the digital output, which is probably the most popular of all of those things, is used to actually switch or power cycle equipment that is connected to this router.
Oh, so you can use this router as kind of a bit of a power hub in the design.
Yeah,
Oh, nice.
absolutely. So generally we find when it starts to perform more than one function. So for example, the Ethernet ports might connect to a PLC, an IP camera, any Ethernet device, industrial controller, BMS system. So obviously there's a value proposition in doing that in the first place, to avoid site visits. But when we extend the functionality to be actually power cycling things as well in the same control plane, it's the business case becomes very easy to prove.
Nice. And just to double check, are those other Ethernets there? Are they just communication, or is one of them or both of them power over Ethernet as well?
No, so there's no PoE on this design.
Okay.
There are other Robustel products that feature PoE, but no, not on this board.
Cool, no worries. So, I mean, obviously this is the hardware part. What kind of solutions are there in terms of? Are you running any specialist software or firmware on there that makes anything easier or takes care of some security for the customer?
Yeah, no, that's a key part of the proposition actually. So, if you implement a cellular module in isolation, you come up with your own design. Then the whole software piece on the board, the PPP dialer, maybe slightly old parlance now, but I'm sure those that have spent any time with AT commands will know what we're referring to there. But there's an entire Linux operating system on board. Vast number of subroutines to take care of things that even connection control, allowing remote reboots by SMS, that you need a handler to deal with all that stuff. So that all comes with it, and that really is the differentiated proposition of buying I guess what we would call a 4G system on module, as opposed to just a 4G module. You get a Linux operating system for free. Nice.
And I guess you've also got, do you have a cloud service as well that pairs with it nicely?
Yes, yeah, cool. Absolutely. That's a big part of the prop these days. So all of the key variables relating to the cellular comms, so signal strength, data usage, ping times, all of that is transmitted to Robustel's RCMS cloud platform, all based in Microsoft Azure. We've just cracked 100,000 devices on there.
Well done.
So it's going in the right direction, and that really is absolutely invaluable for managing estates of devices at scale.
And just out of curiosity, what kind of network size would you propose using this kind of router for in terms of number of devices in an IoT?
It's a good question. Very good question. I think there's probably two ways of answering it. One, from a design engineering perspective, is at what point does this board make commercial sense as opposed to spinning up your own design? And certainly I'd say it's designed to be very cost effective. Robustel buy well in excess of 250,000 cellular modules each year, so you get some advantage of the economies of scale.
Nice.
But so certainly in the low thousands, it would be worth looking at a system on module approach for your 4G comms in a product design. From an actual more real world perspective, probably a similar kind of answer. We've got one particular energy company. They make a kind of building management system controller, and they're rolling out 6,000. So 0 to 10K space, I think, is where there is a business case for this system on module solution, and certainly at the low volume end, it's a no-brainer.
So that's been a pretty good explanation about what Robustel offers and this embedded 4G router itself. But we're going to do another demo which shows you why you might want to buy an embedded 4G router solution system on module rather than sourcing everything yourself.